Hey, welcome back if you saw my introduction video, and if you didn't see it, welcome to my channel. I'm Erin. I'm excited to be here. I'm excited to share my take on science with you guys, and it's going to be multiple science topics. I know chemistry, biology, anatomy and physiology, biochemistry, and others, and I'm going to be going through those on here and trying to help some folks out with how I look at those things. But I'm going to be starting with chemistry. If you had watched my introduction video, I talked about that. If you haven't watched that, go back and watch it. It's useful. It kind of tells a little bit about me and my education, my teaching experience, and pretty much what I'm trying to accomplish with this channel and how I'm setting it up. And so if you'd like to, I encourage you to go watch it. Otherwise, I'm excited to be starting. I'm excited to be starting with chemistry. Chemistry is my first love. What I majored in undergrad, and I had a really cool chemistry teacher in high school. He actually wrote our book. He wrote our book in our physics book, so he obviously really knew the material, and he would do demonstrations in class, and he was just a great guy. So that really put a good taste in my mouth for chemistry. So when I got to college, I didn't have a bad attitude towards it. You know, like I think a lot of people hear rumors about it, and then they start to form opinions about it. I think with chemistry, a huge part of chemistry is who is your teacher. If you have a teacher that doesn't understand chemistry that well themselves, then they're going to confuse you. If you have a teacher that is a rocket scientist and knows way too much, then they're not going to be able to teach to their audience. It's hard to, what they say, dumb down. So hopefully, you guys in your classes, y'all get a good teacher so that when you walk away from chemistry, you love it like I do, because it's really not that bad. It's not really hard. Whenever people would ask me, what's your major? And I'd say chemistry, everybody would always gasp and say, oh, you must be a genius. And I'd say, heck no, I'm not. I just like it. I think whatever you like, you're good at. So don't be intimidated. It's not really bad. Don't let the symbols on the periodic table scare you. They're just letters. And, we don't even need to know that much about them. And then we can do a lot with them. So, don't worry about it. And also the other thing is the math part. I know that a lot of people spread rumors that chemistry, especially Gen Chem, is nothing but math. And, that's true to some extent. There's a lot of concept there too. But the math part doesn't get any harder than just basic algebra. If you can rearrange an equation to solve for X, then you've got it made. That's all you've got to do. So with that being said, I am excited, as I've said a million times. I'm thrilled to get started talking about chemistry. I like to talk about it, and so yay. So I get to talk about it for a while now. And so we have to start off at the beginning, and so the basic unit of chemistry, or the basic idea of chemistry, starts with the atom. And so we're going to go ahead and define it. We're going to have to do a couple of definitions. Anytime you start a new subject, you've got to kind of define the terms that go with it. So first off, we've got the atom. Oh, and also I meant to say this, a couple of things before I start. I'm sorry, I didn't mean to pause. I have listened to these videos and I sniff a lot. I'm not congested. I don't have a running nose. I didn't know I breathed loudly, and now I guess I'm self-conscious about it, I guess. But I don't know. I don't know what that is, so I apologize. And the other thing is, y'all, I have never made videos before, so I know this is really, really basic, but I'm hoping as I start doing this, I'll start, picking up tricks, and I'm sure that I'll want to show figures and show things online and, things like that. And so I know through Zoom, you can do that, and I'm sure I can figure out a way. And so that's coming. This is just the first video, so bear with me. Be patient, please. All right, so the atom. Got a couple of definitions for you. Okay, and so number one, we're going to say this is the basic building block of matter. And if you haven't taken a science class in the past or the recent past, matter is defined as anything that has mass, which is on Earth the same thing as weight. It takes up space. And so this is matter, you're matter, my dog over here on the ground is matter. Pretty much everything is matter except for empty space. All right, so basic building block of matter. And then also it's going to be the smallest piece of an element that retains the properties of the element. And I'll explain that. Okay, and so basically it's saying it's the smallest sample of an element that you can have that you can still say that is a piece of iron. It's not some unrecognizable fragment that is not even that anymore. You can say that is a atom of iron, that is an atom of carbon, and you can distinguish it because it still has all its pieces. It is, still has, all the elements of iron or carbon. And so, what are the elements? The elements are pure substances. You can't get any purer than the elements. And in chem, especially in chapter 1, actually, we'll talk about pure substances versus compounds. And so when we talk about that, in the pure substances category, that's where the elements are going to fall. But another way to talk about the elements is those are the things that are going to be on your periodic table. And so for right now, I went to the teacher supply store, and I was really lucky actually. And I got this periodic table, and I'm sure that I'm going to figure out some other way to be able to more detailed show you. But for the meantime, this is what I got, and I can get pretty close with you. You probably, I don't know, my vision's terrible, but I think you can see those numbers. But this is the periodic table here. And as you can see, every little block has some letters in it, a letter or 2 letters in it. And those are the elements. And so those letters, they represent different elements. And you'll learn to kind of recognize what the different letters correspond to. You'll be surprised, which you'll learn pretty fast. So, for example, C is carbon, O is oxygen, N is nitrogen. So this thing, if we're, being kind of, looks kind of simple, you can do a whole lot with this thing. It's amazing. So we'll be using this a lot. And so when we get closer to where we'll be using it, I'm going to give you a link, or not, just tell you a link to what I feel like is a pretty good periodic table, and just good enough for what you're going to need. And you might want to print one out or whatnot at home, or whatever your teacher in your course wants you to do. But we'll put this down for now. We'll come back to it. So that's what the elements are. And those are your your 2 definitions of your atom. And the last thing we're going to say before we move on underneath this heading is it's going to have 3 components. So your atom is going to have 3 components. Okay, and we're going to call these subatomic particles. All right, I'll give y'all a second at home. If you are taking notes, I recommend taking notes. I encourage it. When I used to teach anatomy and physiology, I had these notes that I had created that when we get to me going through anatomy and physiology, I'm sure you guys won't be, you might be taking that then and come back and use me for that and use my notes and stuff for that. But I would, my class, every day I would do notes on the board, and they would take them, and they would kind of like give them to people in other classes because they were pretty good notes. And I would make them take the notes to get them, because I felt like if you write or draw while you're listening to your instructor teach, it helps reinforce that knowledge. It's just another layer of ways to reinforce it, and you can use all you can get, especially in anatomy. Chemistry is not so bad. Chemistry is just, what I love about chemistry is you learn a trick, and as soon as you can do that trick, it doesn't matter what question they give you, you just do the trick and you got it right. I always in college hated English or anything that was like left up to interpretation, where it was basically like, did my teacher like me or not, determine my grade. I like chemistry and math because like it's either right or it's wrong, and you know, so who cares if you like me. All right, so that's the atom, and then we were mentioning those components, and so let's talk about those subatomic particles. All right, so we've got our subatomic particles, and we have 3 of these. Okay, so we're going to list them. We've got a proton. You probably heard of some of these. P. Okay, we're going to have a neutron. And third, we're going to have an electron. And I'm just going to represent those by their lowercase letters for the time being. And then here for your electron, this is a pretty useful symbol. Pretty much from here on out throughout chemistry, and it's not just me, it's pretty much most teachers, all teachers probably. For an electron, you're going to represent it as a lowercase e with a little negative symbol up to the side. And that will be explained in a second. So let's do a little chart and let's kind of talk about some of the properties of these subatomic particles. All right. And so we've got, we're going to say our particle. We'll just do this over here because I'm going to, just right here. Okay, so we're going to say our particle. We're going to have 3 columns. Mass. And charge. Okay, so we've got a proton. A neutron. And your electron. Okay. All right, so for your proton, okay, these are going to be easy numbers. I know you're probably expecting some crazy like decimal point numbers you got to memorize, but easy stuff. So proton mass 1. Okay, charge on a proton is going to be +1. Okay. Next, where that virus. Okay. Second is a neutron. This one's also going to have a mass of 1. Nice convenient number. And then the charge is in the name. It's neutron, neutral. Neutral means no charge. So your neutron is going to have 0 charge. And then your electron is going to have, we're going to actually say the mass is 0. To be like perfectly specific, then mass is like 9.1. It's like 9.1 times 10 to the negative 28 grams. So, that is so little. We're just going to say 0. So don't worry about me. So keep it simple. And then the charge on the electron is going to be opposite that of the proton. And it's going to be -1. Okay. All right. And so that is just kind of the overall explanation of your subatomic particles. All right. And so I am going to erase this. And we're now going to talk about the structure of the atom. Okay. So we're just moving on through. All right. Next, we're going to say atomic structure. Okay. All right, and this is my take on this. And this is something that I have felt since day 1 in chemistry, is I think the structure of the atom is eerily similar to our solar system. So I'm going to say similar to our solar system. Okay, and so why do I say that? What do I mean? Okay, so one thing is, okay, it's going to have a massive center surrounded by less massive objects. All right, so in our solar system, we've got the great big sun right in the center. And of course, that's way bigger than all of us. So obviously, that's the massive part. Okay, and so we're going to say the center is going to be referred to as the nucleus. Okay, and okay, we said the center is the massive part. And so if you remember, I'm just going to write this up here just for y'all. We've got a proton, a neutron, and an electron. Proton had a charge of +1 charge. We don't need that for now. We're just going to say, remember, the proton had a mass of 1. So say mass. Proton had a mass of 1. Neutron had a mass of 1, if you remember. And your little electron had a mass of 0. So here, we said it has the massive center. So your center is going to be your nucleus, and it's going to be the heavy thing. So it's going to be your protons plus your neutrons. All right, so let's go over here and let's draw kind of like a little model. All right, so we've got a center, and I'm going to call that the nucleus. I'm just going to write nuke for nucleus. And here we're going to have both our protons and our neutrons in there. And then they're going to be surrounded by those less massive objects, and those are going to be your electrons. And so you're going to say the electrons orbit the nucleus in electron shells. That's what we call them, is electron shells. Okay, and so here you have your nucleus in the center, and let me kind of get some color in here. All right, and so here you have your, like, think about our solar system. You've got your first orbital out, you've got Mercury, right? So here you'll have your first electron shell, and it's like, you know, a certain energy out or certain, you know, distance out from the nucleus, and it's going to have some electrons. And then you'll have another electron shell farther out, and it'll also contain some electrons. And so that's how I like to think about it, is it looks so much like the solar system, resembles the solar system, and then it helps me remember the stuff that I need to know for class and I need to know for the subject. Okay, so that's it for the structure, and we're almost done with this topic. The last thing that we got to talk about are those symbols, and there's nothing hard about this. So this is super simple. Let me do that. All right, this is the end of it. All right. Make sure that looks good in here. That's perfect. Okay. All right. So our symbols, last topic. Okay. And so I'm going to say our symbols are going to have 4 pieces of information. And I'm just going to write info, period, for information. All right, number 1, you're going to have, it's going to be the identity of the element. Okay, and so by that I mean it's going to be a 1 or 2 letter symbol. The second piece of information you get, or let me go ahead and start writing. This is the way that you're going to see most of your symbols written. Let's just use something simple from the periodic table like carbon. Okay, so we'll see carbon has the symbol C. All right, so you're going to see your letter, or 1 or 2 letters. Okay, second piece of information is something called the atomic number. Okay, this is what I call the fingerprint of the atom. Okay, this is also equal to the number of protons. Okay. All right, you're going to see that in the upper left-hand corner. All right, so I'll say that also. upper left-hand corner. All right, so here, carbon has 6 protons, and so we're going to put the 6 here, and I'm going to say this is your atomic number right there. Let me do my arrow a little darker. There we go. All right, so far so good. Nothing complicated yet. We're almost done. All right, so third piece of information, excuse me, is going to be your atomic mass. Okay, and this is going to equal, you know what? Let me back up. I'm a bad teacher. Okay, don't worry about that. Let's go back up to here where I said the atomic number is the fingerprint of the atom. Okay, let me explain that. I'm sorry. The number of protons is going to determine the elements. The element identity. Okay. By that I mean that if you have an element that has 6 protons, no matter what, that's carbon. If you have an element that has 7 protons, no matter what, that's nitrogen. The number of protons in an atom never changes as long as it's still the same element. So protons for a certain element are constant. So that's a very valuable tool. So as you'll see, I'm going to do some sample calculations, which your teacher can kind of make you questions for with this. In your sample calculations, one valuable piece of information is either the identity of the element, if they tell you what element it is, or if they tell you the number of protons, because if they tell you either one of those, then you know the other. So like if they say, I have an element, it's got 7 protons, what is it? Automatically, you can just go straight to the periodic table and know. Or if they say, I have carbon, how many protons does it have? Doesn't matter. If it's carbon, you can go and know. So this number of protons is very useful, and it does not change for a given element. Okay, back over to the atomic mass. I'm sorry I got out of order there, but the atomic mass is going to be your number of protons plus your number of neutrons. Okay, and that makes sense, right? Atomic mass is basically how much does the atom weigh? Okay, what are the things in the atom that have mass? The protons and the neutrons. Electrons are essentially 0, so we're not even going to throw them in there. So for your atomic mass, it's going to equal your protons plus your neutrons. For carbon, it happens to equal 12. Okay, so we're going to say here's your atomic mass right there. Okay. And then the very last piece of information that I'm going to mention is a charge. Okay, does the atom or element have a charge to it? And so I'm going to go ahead and say that if you're getting an atom or an element off of the periodic table, they are all electrically neutral. Okay, so we're going to say all atoms on the periodic table are neutral. And that's something valuable to know, because that tells us that the number of protons is always equal to the number of electrons. Okay, so for something to be neutral, that means the number of pluses equals the number of minuses, because they cancel each other out. If you go back to that chart we made, protons were +1, electrons were -1. So if you have 6 protons, you'll have +6. If you have 6 electrons, you'll have -6. Those two cancel out. So remember that. Protons and electrons are equal as long as you're talking about something on the periodic table. And so for something that has a charge, whether it be 0, 1, 2, -1, it's going to appear in the upper, so we'll say it's shown in the upper right-hand corner. Okay, so right here is where you would put your charge. So I'm going to say right here, we're going to say charge. Okay, and then I'm going to make a note that if there's no charge, I'm sorry, if it's blank, there we go, this is a better way to say it. If it's blank, there's no charge. Or the charge equals 0. Okay. Just add these notes at the bottom right here. So right under there, under that bullet point. Next thing is if blank, it's no charge or the charge equals 0. And one last thing we're going to say is that we're going to make one more definition, and we're going to define something called an ion. And an ion is a charged atom or molecule. And a molecule is just some atoms. I'm actually going to write this down because I think it's going to go out of our field of vision. So atom or molecule. All right. So we'll talk more about ions. We'll give you a specific definition for like what's a positive ion called, what's a negative ion called. This is all going to come back up. Right now, what I wanted you guys to take home was, okay, your atoms have 3 particles, protons, neutrons, and electrons. Make dang sure you know the mass of all those. Make sure you know the charge of those. Okay. Make sure that you know, if you look at one of these symbols, what each of those numbers represents. Because if you don't know and your teacher asks you, you can just get that wrong. So, but it's an easy thing to get right on a test. This is free points if you can manipulate this and answer questions with it. So to end this off, I want to go ahead and kind of show you what your teacher going to do. How's your teacher going to ask you about this? How could they put this on a test? So you actually have learned something that you can get asked about. So I'm going to erase all this, and I'm just going to say sample problems or something like that. And we're going to do a few, and that will be it for this one. And then I will move on. All right, so we're going to say calculations. I'll just call it calculations. We'll say, hey, calculations. And I'm going to give you, let's do 3 or 4. Let's go ahead, and this is what I anticipate seeing. And like I said, if you need to do these with me and you want to kind of go along, go online. You can go to a site called ptable.com. It's got a really cute, colorful, interactive periodic table. I'm sure there's tons of them out there, but for the time being, I'm going to be stitching this with the other video. I forgot to define something, so I'm going to add one more thing before we do calculations. And I wanted to find something called an isotope. Okay. An isotope is I'll say isotopes. So there. Isotopes are atoms with the same number of protons but different numbers of neutrons. Let me just go ahead and give you an example. I'm just going to erase it before we do the calculation. So you've heard of carbon-14 dating, right? I'm sure y'all all have. Okay, and so carbon-14 is an isotope of carbon. So basically, carbon, as we said in the lecture, if you have an element, then if it is carbon or it is oxygen, if it is whatever element it is, you automatically know how many protons it has. So for carbon, we'll say we've got carbon-14, and 14 would be the atomic mass. And if you look over here on your periodic table, you can see carbon has an atomic mass normally of 12. Okay, and that's actually, the one on here is a weighted average of all the isotopes that occur naturally. So you got carbon-14, you have carbon-12. So I'm going to write the symbols. So you've got carbon and carbon. And so if you go over to your periodic table, how many protons does carbon have? Always, no matter what, if it's carbon, how many protons? And so you would go over here and say, okay, where's carbon on my periodic table? And you would find it. And on the periodic table symbols, the atomic number is actually up here in the corner. Kind of the same spot as in the other symbols. And then the mass is still at the bottom. It's just not kind of kicked off to the side. It's on the bottom. So carbon has 6 protons. All right, so we know it's always got 6 protons. And then, so this one is carbon 12, and this one's carbon 14. So what's the difference is, if this is equal to protons plus neutrons, if you have carbon 12 and you have 6 protons, then it's got to have 6 neutrons. Well, here you got 6 protons, that's equal to protons plus neutrons. So 6 plus what equals 14? That would be 8. So this one's going to have 8 neutrons. So it doesn't change the identity of it, just makes it a little heavier. You know, it makes a difference in chemical reactions sometimes. And, you know, other useful, you know, other valuable uses of them, like with the dating and other things. Okay, so now that you know what an isotope is, you have to kind of know that to know what I'm talking about with the calculations, because the word isotope is going to be in the problems. All right, so here, let's go ahead, and this is going to be how these questions are asked. I've already got it written. Oh, wait, no, I've got to rewrite it, but I'm going to write kind of a general question, and then we're going to do specific things. So I'm going to say, how many protons, neutrons, and electrons in the following is the question. Are in the following. Okay, question mark. Okay, so number one, we're going to say, and the isotopes are usually written like you've even heard it. So carbon 14 dating. For an isotope, they'll like say the name of the element and they'll like write a dash and they'll write the mass after it. And so we'll say how many protons, neutrons, and electrons are in the following. Let's say calcium 42. So how would you do that? I'm going to go ahead and walk you through 2, and then I'm going to do a third one. Not going to do anything. Going to let you do that at home. I'm going to sit here for a second. Then we'll check it and see how you do. All right, so calcium 42. How would I go about that? First thing I would do is I would go to the periodic table, and I've got to find calcium, and it happens to be right here. So, okay, so I've got calcium. I look over. I find my atomic number. Okay, it's going to be 20. Okay, we know since it's calcium, it's always going to be 20. So we're going to say protons equal 20. Okay. Now, we don't know. We got to calculate the neutrons because it's not explicitly given on there. But electrons, how do we know? What do we know about electrons? How do I know how many electrons calcium has? So I'm going to leave a little blank for my neutrons and my electrons. Okay. If you remember when we were talking earlier, we said all those elements on the periodic table are going to be assumed to be electrically neutral. So if something's neutral, it has just as many positives as it has negatives. And so protons and electrons are going to be equal. So for here, calcium, if it's got 20 protons, we're just going to go ahead and say, yeah, it's got 20 electrons. And so the last step is to calculate neutrons. Okay, so this is the atomic mass. We know our mass equals, we'll say our atomic mass equals protons plus neutrons, right? Okay, so this is how you'll do it. You say, okay, well, for calcium 42, I've got 20 protons and don't know my neutrons. And so, like I said, the math is going to be like basic algebra. Got to get n by itself. How do you do that? You've got to get rid of the other item on the same side of the equation. So you're going to do the opposite of what it's doing here. Here it's a positive 20. To get rid of it, we got to subtract it, right? Okay. And that leaves you with 22. All right, so here we'll have 22. Okay, one more. Okay, we'll say, what about bromine? 82. Okay, So I'm going to walk you through that. All right, so first thing you always do is you go periodic table, use that identity bromine, because if you know the identity, you automatically know your protons. So here we go, bromine's right here, 35 protons. Okay, electrons, going to be the same because they're always equal. And so then to do your neutrons, we've got your mass, 82 equals your protons plus your neutrons. So we got to get rid of that 35. Okay, so we've got N equals 42. All right, and then I'm going to give you one more, and I'm going to sit here, and I am going to let you try to do it, and then we're going to check it, and that's going to be the end of this first video. And we're going to move on to another little topic. Okay. All right, so here we go. It's going to be number 3. And I will say strontium dash 89. All right, PNE. All right. But what am I doing? You guys can pause the video. Okay, so I don't have to sit here. Okay, so strontium, let's go to our periodic table. Hopefully y'all remembered how to do it. Right here, 38 protons. Okay, so we can go ahead and drop that number right there. 89 equals protons plus neutrons. Okay, get rid of that 38. Is that right? Mm-hmm. Okay. And so N is going to equal 51. So hopefully y'all got that. Hopefully it all made sense. Like I said, next video we're just going to move straight on to the next chapter, next topic in chapter 1. I know I'm a little bit behind. I'm a perfectionist, and the fact that I had never done videos before and the lighting was terrible. I had things shining on the board. Oh gosh, it probably took me forever to even like get where I was okay with like even filming. So I am going to bust this out, though, and I'm going to catch up, so don't even worry about it. Before you know it, I'll be on the same page as your teacher or whatnot. So have a great night. Thanks so much. Bye.